This is Freethought Forum, a program by the Atheist Society of Knoxville and the Rationalists of East Tennessee. I'm Faithless Forrest.
And I'm Ralph Eisler. And we want you to know that if you don't believe in God, you're not alone. Right here in East Tennessee, you can find free-thinking people, atheists, agnostics, and humanists. This is a show for them and for people committed to a life rooted in science and unfettered by supernatural beliefs.
Today's show topic is The Lives of Stars and the Story of Dust.
Why do the lives of stars matter to us atheists?
All lives matter. Oh man, that sounds bad in this context. But we are star stuff, as Carl Sagan says, and so we're going to talk about that today.
Right, good. Okay, but first we want to tell you viewers a little bit about the show's sponsors.
The Atheist Society of Knoxville frequently has a fun meetup at a bar or eatery. Tonight's meetup is at Barley's in the Old City, starting around 5:30. Look for the silver-jacketed copy of The God Delusion standing upright on the table. And as Matt Dillahunty at Atheist Experience says, everyone is welcome to our happy hour for food, drink, and conversation. But if you plan to preach, proselytize, provoke, or punch, please don't.
Now, the Rationalists of East Tennessee have several regular monthly meetings. The first and third Sunday mornings of the month are usually lectures and lively roundtable discussions. The second meeting, we hold the Skeptics Book Club in Books A Million over on Kingston Pike. On the fourth Sunday, we mix things up a little. Sometimes we have a get-together we call a reflections meeting. It features potluck lunch in somebody's home. Sometimes we play board games, watch a movie, or similar activities. Now and then we have a blood drive, too.
Later in the show, we will give you our websites to visit for additional details, including times and locations. So let's work on over to In the News. Well, today I saw this headline on CNN that the Catholic Church is declaring a new saint, Mother Teresa.
How often do they declare saints?
I think they've been trying to do so more frequently. I think it's to raise their visibility.
Yeah, John Paul II seemed to have a real contest going there to see if he could out-saint the previous guys.
Christopher Hitchens referred to it as fast tracking. Well, and I think John Paul had started the process. And so who is this Mother Teresa, we say? She's a nun who dedicated her life to helping the poor in India and can be canonized as a saint on September 4th. Pope Francis announced on Tuesday. I guess that's today. We're reading a CNN article here.
Yeah.
The date falls on the eve of the anniversary of her death, which occurred on September 5th, 1997. In December, Pope Francis announced that Mother Teresa would be declared a saint after recognizing a second miracle attributed to her: the healing of a Brazilian man with multiple brain tumors after loved ones prayed to her. The Italian Catholic Bishops Association's official newspaper, Avvenire, reported that the miracle occurred after her death.
Well, that was the same with John Paul. He's now, as John Paul II, he's now a saint too. And the miracles occurred after death. I'm always curious as to how this happens.
Yeah, I'm sure they've got plenty of proof.
Yeah. Well, the nun was beatified in October 2003 by now deceased Pope John Paul II. He approved the first posthumous miracle. A 30-year-old woman in Kolkata, that's old Kolkata, said she was cured of a stomach tumor after praying to Mother Teresa. A Vatican committee said it could find no scientific explanation for her healing and declared it a miracle. Mother Teresa was born in 1910 in Albania and baptized Gontia Agnes, the Vatican said in her biography.
Yeah, well, my goodness, it just amazes me that they can just take someone's word that a stomach tumor existed, couldn't have spontaneously remitted, and therefore it has to be a miracle.
If I remember this correctly, there used to be a committee of physicians that the Vatican submitted these cases to. And the committee would look into it, and they would declare whether it was a miracle or not. But I believe it's been about 4 or 5 years ago now that they have quit doing that. because they've seen enough cases of spontaneous remissions that they're no longer willing to put themselves on the line saying it's a miracle or not. So they just tell what they observe, and they leave it up to a committee of priests to determine whether it's a miracle.
Wow, imagine that. Well, at age 18, Agnes joined an Irish convent where she received the name Sister Mary Teresa. Months later, she left for India, landing in Kolkata?
Yeah, Kolkata.
The city then known as Calcutta. All right. And in January of 1929, she taught at St. Mary's School for Girls. All right. Oh, there she took her final professional vows and became Mother Teresa nearly 20 years later during a train ride in India. She said she felt a calling from Jesus to care for the poor, and her Vatican biographer reported. She established missionaries of charity to serve the poorest of all. In 1948, she donned her iconic white sara and blue trim for the first time and walked out of her convent to start her life caring for the poor. She washed the wounded, cared for the sick and dying, and some of her former students joined her over time. She spread her work throughout India.
In 1979, Mother Teresa even won the Nobel Peace Prize. Pope John Paul II waived the requirement of waiting 5 years after a person's death to pursue the path to sainthood and opened Mother Teresa's cause of canonization less than 2 years after her death. Now,
so that was this fast tracking, I guess.
That was the fast tracking. Now, this all makes her sound like a very saintly and caring person, but Christopher Hitchens did a biography of her that was called The Missionary Position.
Right.
And it was anything except flattering. And what was the quote you gave me? She was in love with poverty, not the poor?
I think he said that Mother Teresa, well, he would refer to her as Agnes, was not a friend of the poor, but of poverty.
Yeah.
And in fact, I've seen other documentaries. I've seen documentaries about her, and she essentially operated a not very comfortable bedding area where people could die with
in childbirth or other ways of being neglected.
Without adequate medical services, even what we call palliative care. She seemed to think that suffering was good for people.
Yes, she apparently said that quite directly. And that was one of the things that Hitchens was mad about. I remember one time he said that the only time he really wished there was a hell was so he could see her in it.
Yeah.
So anyhow, it's.
But she's on a fast track. When I've met Christopher Hitchens in person only once. He came here to Knoxville, and he spoke at the University of Tennessee.
Yeah.
And in that speech, he spoke about this kind of interesting event that the committee in the Vatican that meets to decide about these things for the miracles and the nature of the person who's being proposed as for beatification or sainthood.
Yeah.
Used to include people to argue the other side. They were, and
The devil's advocate.
he used the term the devil's advocate. And apparently that was at one time like a paid position within the Vatican. And I'm not sure if he implied that it was actually John Paul who abolished the position, but he was somehow invited to testify, and he made the joke that he acted as the devil's advocate and that his work was pro bono. All right. Well, you can understand why, the Catholic Church is going to want to declare saints. It makes their institution seem relevant in a day and age when you've got to think that without them trying, it's going to be pretty obvious that modern medicine helps people far more than anything a priest, a pastor, or a nun ever did.
Yeah. These These saints apparently were a growth out of the early Christian church, which replaced the old Roman household gods, the Lars.
I know nothing about this.
Yeah.
And what was their function?
Well, they were personal household gods that most households had, you know.
And
but
you
now we
called
got
them Gars?
Lars.
Lars. all right.
L-A-R-S. And now, you know, the saints, we have many saints. There are saints for sailors, okay? There are saints for pregnant women and all this. So they're identified sort of personally with certain groups of people rather than with particular households. But it's my understanding that this was the origin of these saints as Christianity replaced the pagan religions.
All right. I think I've kind of heard speculation that they kind of crept especially out, or that they maybe became popular in Egypt. Egypt had, like, for instance, a patron saint of motherhood or pregnant women.
Yeah.
And that this sort of enthusiasm for individuals to pray to for specific life situations led to the creation of saints. I know one of the earliest saints that I know of is Saint Cyril, who is a bishop, I think it would have been
Yeah.
in Alexandria,
Yeah.
and this would have been in the 400s. So, you know, that was happening in Egypt as Christianity was displacing the indigenous previous religion.
Yeah.
Well, I must remark that I'm also aware I come from a background designing television, and there's even a saint for television.
That I did not know.
They've got them all. I think her name is Clara, and she apparently couldn't make it to some church service, and so she imagined she saw it, and she's the saint of television.
Okay. That's a new
I've
one
never
on me.
seen any television actually that has failed actually come back to operation by any appeal to this saint or anything, though.
Simply praying.
Yeah, I think that a multimeter, or in the old days a tube tester, would be far better for
Yeah,
you.
I never tried it on my television. I've tried it with my computer, and I guarantee it doesn't work on computers.
A clenched fist and threats is what I've used, but that doesn't help either.
Well, the Genius Bar at the Apple Store is best for me.
All righty. Well, today we wanted to talk about the lives of stars. It's often said by those of us in the non-belief community that, you know, forget this nonsense about Jesus dying for your sins. There are stars out there that died to make the atoms that make up our body. And I am an avid amateur astronomer, and so I put together some notes about that. And so if we could get our first slide up here, which is about galaxies. So galaxies stem from a Greek word. The word galaxy means like the way of the milk, or Milky Way, and we use the phrase Milky Way to also to describe our galaxy. And
You may have to back off a little there, Sam, to get the whole thing.
yeah,
in.
we're kind of filling it all in, but
Okay.
between us here, between you and I, is a photograph of a galaxy that can be seen in the southern sky around this time of year, and it's called Centaurus A. Centaurus A is, I would guess, is probably about maybe the third biggest galaxy in terms of the angular size here that we see from Earth.
You've seen almost top on there. I mean, almost from the top. That's what.
Well, it's a complex picture. It happens also to be the strongest extragalactic radio source. The center of our galaxy is a radio source, and it's stronger, but next in order is this. And what it is actually is it's a complex thing. It's galaxies merging, and there's a lot of dust in there. And when galaxies merge, the stars are so sparse and small that they tend to pass one another without collision, but the dust interacts. And Centaurus A is, well, it's in the constellation Centauri, or Centaur, the centaur, half man, half horse, in the southern sky. And this is going to be at its highest point, probably about, around 2 a.m. this time of year. And with a pair of binoculars, you can see this round area, and you see the dust band cutting across it, and it's a marvelous thing. Now, up above Ralph here, we've got a galaxy in a different configuration. That's a spiral galaxy, and it has dust as well, but it's much harder for us to see because we're looking what's called face-on.
Mm-hmm.
But often where there's dust, there's star-forming regions, and the star-forming regions often fluoresce red. And so in the spiral over Ralph's head, it's a veritable halo. There's lots of knots that are red. And what that galaxy is, this is a galaxy right off the end of the handle of the Big Dipper. I have seen this with handheld binoculars. Now, when I say seen it, what it looks like is sort of two faint patches of light. There's no detail you would see in binoculars.
Yeah. Sure.
But these are two galaxies, and they're interacting. And once again, their interaction is quite a bit in the nature of dust. There's a dust trail that connects the two. And there's a lot of star forming going on now because the gravitational interaction of the two tends to cause the steady state of dust to reconfigure in a way that falls together and is forming stars.
Uh-huh. Are there any dust mites out there?
I would think that if we think of whole solar systems as mites, yes, they are. Maybe dust bunnies. Solar
Dust
systems
bunnies.
are dust bunnies.
Yeah. You mentioned colliding galaxies. Our own galaxy, Milky Way, is on a collision course with the Andromeda Galaxy. I forget how many billions of years off. Right
Around
now,
1 billion years from now,
Yeah.
it'll have begun to significantly merge with
Yeah.
us.
So that, if there's anyone still living here, then that will make for perhaps a little bit of upset from time to time.
Well, what will happen is there'll be star-forming regions like
Right.
over your head here. As the collision occurs, it's causing compaction, and this compaction it'll be kind of analogous to in the Earth's atmosphere when regions of different temperature interact with one another. That tends to cause cloud formation and precipitation.
Right, exactly.
And it's kind of an analogous phenomena. So in the Earth's atmosphere, when masses of air of different temperature interact, we get rain. Out in the universe, when masses of stars interact, actually masses of dust interact, the stars rain out.
Yeah. Well, that's pretty interesting. I wonder if there will still be a Congress around then with some dust deniers in it.
At dust deniers, yeah. Apparently, we're getting the flag here. We got a call. You want to push the button and greet our caller?
Hello, caller. You're on the air on Freethought Forum. Could you give us a name or nickname?
Charles from Central Illinois.
Hello, Charles.
Good to hear from you.
Yeah, I thought I'd call and talk about star stuff as your today's primary is.
Sure.
Sure.
You were talking about galaxies. One of the things that I noted recently is it seems as though galaxies formation was helped by the formation of very large black holes. These would have been the first black holes generated during the first part of stellar formation
Mm-hmm.
around 13 billion years ago, when the universe was still very young.
Yeah.
In fact, well, later in the program, I've got some information about the early stars, but the early stars, because there was less. In the earliest stars, there were no heavier elements. They were hydrogen and helium. And the nature of stars formed out of only hydrogen and helium is that they tended to grow very big before they reached a steady state. But big stars also don't live long, and they process their fuel and contribute waste material to the universe. And that's the dust about which today's program is. But these large early collections would have left behind compact remnants that may have merged, forming the large black holes that are in the center of most galaxies. And I think we can say that I think it's pretty certain that virtually all galaxies harbor at least one large black hole. And by large black hole, we mean something that has a mass on the order of hundreds of thousands of stars, if not millions.
Yeah, hundreds of thousands is, I think, the bottom end of the scale for galactic
Yeah.
supermassive black holes, except for the center. Interestingly enough, the man that came up with the idea of nuclear synthesis of heavy elements, Sir Frederick Hoyle, is the man that came up with the mocking words, the Big Bang.
Yes, that's true. Yeah, he did. He used it somewhat derisively, but it caught on and is just part of the normal vocabulary these days.
Yeah.
And,
Well, Charles, do you ever look through telescopes at the night sky?
actually, I go to APOD, Astronomy Picture of the Day, all the time.
All righty. Well,
And
part of
I wish I could afford a good telescope, but I can't at this time.
Well, part of my mission here, or message for today, is that the way you can get involved is to find a local star party. Undoubtedly, where you live, there are astronomy clubs, and they will often have star parties. Usually, it'll be on the weekend near the new moon. Now, they might do it. They might do it after the new moon, so that you can observe the moon as well. And so this weekend, there could easily be star parties going on near where you live. And if you're in central Illinois, far enough away from Chicago, maybe the sky's dark enough.
I'm down where Champaign-Urbana is, where the University of Illinois Champaign is.
Uh-huh.
You want to talk about star parties? We've got a good number here.
All righty, well,
good.
that's great. And the most important thing is go to a star party and look through other people's telescope before you buy your own, because you don't want to rush that purchase. You're better off, in fact, the first purchase you should make is an astronomy or a sky and telescope magazine. And the answer is, well, buy one month and the other month, and keep alternating until you decide on which one you like, because they will give you situational awareness about what you can see in the night sky.
Yes. I'm really looking forward to some of the photographs from the James Webb telescope. And it's going to do the same thing to what we know now, what Hubble Space Telescope did to what we had before.
Yes, it'll be a nice advance.
Yeah.
Sam, bring the background back up again. The image that Ralph and I are sitting in front of, these are all galaxies that you can see right this time of year in the spring. The galaxy that's floating over my head is the famous Sombrero Galaxy. This is a Hubble image of it, which shows far more detail than any amateur telescope will show.
And if you put your head up just a little higher, it would look like you have a halo,
I would have a halo
around
completely.
your head.
Yeah. But what's cool about the Sombrero is that its dust lane is so easy to see, even in small telescopes. And it's just a wonderful thing to start out with. It's a little bit above and to the east of a constellation that's easy to find called Corvus the Crow. And it's actually one of the southernmost members of something called the Virgo galactic cluster, which is a springtime object like this. All right.
Now, getting back to the our we made of star stuff,
Uh-huh.
I listened to the concept of nuclear synthesis. They've been studying all the various different isotopes that are make up the elements
Mm-hmm.
in the world. And several people have come to the conclusion that it wasn't just one star that exploded, generated massive amounts of things, but multiple stars that coalesced into the gas dust cloud that became fulminated into our planetary system.
All right, it's like you've got our script in front of you. Sam, move us on to the next picture where we talk about the dust collapse and star forming. All right, well, man, I'm blocking it badly here. All right, off my shoulder here is this big red cloud. This is called the Lagoon Nebula. This is a star-forming region. It's visible if you were to get up at about, right before dawn this morning. Up over Ralph's head is the Great Nebula in Orion. Orion is visible right as the sky gets dark tonight, and the constellation of Orion are three prominent stars. That's the belt. There's three stars that are below that. That's the sword hanging off the belt of Orion. And the center of those stars is actually what's over Ralph's head here. This is a star-forming region. It is a cloud of dust and gas that has fallen together under its own gravity, and there's stars being made in there. I think there's on the order of, more than 100, but probably less than 200 known stars or forming stars in there right now. Now, right over Ralph's shoulder is a further magnification of something in the Orion Nebula. It's called, I might mangle this, is it a propylid is the term they use? I don't know that I may not have it written down here.
Yeah.
I'm not sure.
But it's sometimes referred to as a cocoon around a forming star. So that object there is bigger than, let's say, Pluto's orbit around our sun. But within inside that is probably a star, a solar system forming.
So are you telling me there are stars actually forming now? That they weren't all formed 6,000 years ago in one day? Or
I'm having to break that to you and the viewers that this star forming stuff's going on right now all the time. Any clear night with a telescope, you could see stars forming. In the winter, in the summer, you can see it happening right now.
Well, I'll be darned. I bet there are a lot of people who don't know that.
That's right. If according to the Bible, the stars were made on the fourth day after the plants were made, but they're happening right now. Now, Charles, I thought you were actually going to kind of lead into a question that didn't go quite the way I thought. Our star is referred to as a third-generation star, meaning the material in it.
Let me see if I remember full terminology. We are a third-generation, semi-variable type G2 star. And that's the third generation refers to what kind of metals and so forth we see in the spectrometry of our star. And what minor variable means we get the 11-year sunspot solar cycle.
And the G2 part.
G2 is the predominant markings of our spectrum and mass.
So you bring up a point here, at least indirectly, and that is, it sounds like there are a lot of different kinds of stars, that not all stars are the same.
I'll be that fine girl, kiss me.
All right. Well, we have some things a little later in the program where we will get to that. But you've helped move our conversation along a lot. Why don't we thank you, and we can hopefully, and once again, I encourage you to go to a star party, and maybe the next time you call in, you'll tell me that you did follow through on that, okay?
Okay.
Okay, good to hear you.
All righty, let's say bye for now. Thanks, Charles.
Bye, Charles.
All right, so we got these star-forming regions that you can go out and see any night. Now, what is hard to appreciate unless you're out under the real sky is that both of these star-forming regions are near the Milky Way. Near the Milky Way is a plane that cuts across our sky. The summer Milky Way is very prominent. The winter Milky Way is less so. And the Orion Nebula is not in the plane, but it's just off the side of the plane of the Milky Way.
I can't tell you the last time I saw the Milky Way. I was a callow youth, probably, when I did.
Here in East Tennessee, there are several astronomy clubs. Some go up to Norris Dam area, which gets you north of the city. Some go down to the south of the city, either on the Foothills Parkway, or venture even further south to the Cherahalla Skyway. The Cherahalla Skyway has the advantage that there's altitude as well.
At Rhone State in Harriman,
Don't they have a little planetarium?
There are two educational institutions in the area. The University of Tennessee has, they have telescopes up on the roof of the physics building. That's on the, maybe like the first and third Friday of the month. You better look on their websites to find that out.
Yeah.
But it's usually a Friday evening. Out to the west, the Roane State Community College was gifted some property out away from the college. It's not actually on the college campus, but it's near the Tennessee River on a little bit of a promontory, and it's further away from the city lights. And what's nice about that facility is that there's a classroom. So it's a rain or shine event. So if the weather looks marginal, you go anyway, because if the weather improves, great. You'll look through telescopes. If the weather isn't, well, there's a classroom, and you can do a little bit like what we're doing here, which is talk about what you can see. You know, because there's an indoor area, you know, you can get warm. You know, half of the year is much cooler than the other half. The Orion Nebula that you see there is something we can see right now. When it gets dark this evening, it's high. But within about 4 hours, it's rotated to where you're not seeing it much. Now, 2 months ago, it would have been high at midnight and very good to look at. But of course, 2 months ago, you would have gotten cold looking at it as well.
Right.
And so what's nice about the Roane State facility is that, you know, there's a classroom area where you can get warm, go out, look through some telescopes some more, go in, talk about what you see, get warm again. So the Orion Nebula is a place where lots of stars are forming now, and there's still a lot of gas. That gas fluoresces because the young stars usually include a few massive ones that emit a lot of ultraviolet light. That makes for something very much like a neon light fixture, only this is mostly a hydrogen light fixture. Much of the red there is glowing hydrogen. There is actually glowing oxygen that emits in the cyan, and often in these things there will be some non-trivial components due to helium and maybe sodium. Let's move to the next slide. So what happens next is that the gas is heated by those young stars and it begins to dissipate. So over my head is a region where the stars have dissipated most of the gas. This is a star cluster called the Pleiades, which the Pleiades may be still visible right at sunset. They're going to be way over in the west. They're called the Seven Sisters as well. They are about as big, when you hold your hand out full length, your thumb is about the size of that star cluster. And when you look directly at it, you'll see stars, but if you look slightly to one side, you see a whole patch of light. And that light is a combination of the glowing gas plus some of the not as bright stars. Once again, that cluster has something like, it's called the Seven Sisters because there's maybe 6 or 7 bright stars, but it's a collection of really about 100 stars again. Between us is something called M6. This is an open star cluster that you would see most easily when summer comes. Once again, you could see it. You could see it today if you got up right before the sun rose. And then there's one star cluster that a lot of people know about, but we don't even think about it as a star cluster. And that's over Ralph's Head, and that's the Milky Way. Sorry, the Big Dipper. Most, but not all, of the bright stars in the Big Dipper have a common motion. They formed out of a cloud of dust and gas together, and they are all moving towards, probably the way to describe that is east, and it's hard to understand why that is from that diagram.
I'll take your word for it.
Yeah, I'm about to say I'm not even certain I have it myself. But then 2 stars, the star on the very end of the handle, and then the star on the far end of the Dipper, they have an independent motion. They weren't formed out of the same cloud.
But even the Dipper itself, though, over a few thousand years, will distort somewhat.
And change shape.
Change shape.
So, Sam, we've got a video here, and if we could play that, this represents something like about 300,000 years worth of stellar movement. If we can get this to play, it starts at about 150,000 years ago, which was the beginning of the last ice age, and it comes through the present, and then it'll go 150,000 years in the future, which, if it weren't for man-made climate change, would take us through another ice age. All right, will it play? All right, so I'm sure that the viewers can still see us, and you'll notice that some of the stars move real fast, and a few move only slowly, and when the video comes right to the end, there'll be a brief flash, which maybe we missed, showing how the Dipper will be very, very distorted.
Yeah.
So the stars do move around us. It's just that during a single human lifetime, you will not notice the change.
Well, the one place where you notice the change is these astrologers who are interested in the zodiac signs. They, unfortunately, when they were first assigned to certain dates, they no longer appear within those dates in the place they're supposed to.
Well, the signs of the zodiac work out like this. There's Aries,
First the bull and then the ram.
Taurus.
And then the heavenly twins, the Gemini.
Yeah. Well, there's a mnemonic, and I was half laughing to myself. So there's a mnemonic I use to remember it. It works like this. It's a preposterous sentence, and that's why it's easy to remember. Ram, bull, twins, crab, liverish, scaly scorpions are good water fish. So the ram is Aries, bull is Taurus, twins Gemini. Crab is Cancer, which is a crab. Liverish is a sort of an artificial thing. It's actually two of the signs smashed together. The live is the word liverish is a Latin word meaning a little bit sickly. And the L part in the beginning echoes Leo the lion, and the V part is Virgo the maiden. Scaly scorpions. Well, scorpions don't actually have scales, they have exoskeletons, but there are a pair of celestial weighing systems or scales in the sky. That's Libra, then Scorpio the scorpion. Ramble twins, crab, liverish, scaly scorpions are good water fish. The A is the archer, which is the sky's second centaur. There are two half-man, half-horses in the sky, and Sagittarius is the other one. He is an archer, but he's also a centaur. What follows him is Capricornus, the sea goat. So scaly scorpions, ramble twins, liverish, scaly scorpions are good water fish. So the G is the sea goat, water fish is Aquarius, and fish is Pisces. So that's how we remember them all. I hadn't planned on talking about the signs of the zodiac here.
No, I just brought that in. Maybe we should take a little program break.
All right, we are past the halfway point. Sam, if we could get ready for that. This is Freethought Forum, a program by the Atheist Society of Knoxville and the Rationalists of East Tennessee. Freethought Forum is funded jointly by them and by individual contributions.
Shows are live most every Tuesday from 5 to 6 p.m. Eastern on Knoxville Community Access Television. That's Channel 12 or Channel 194, depending upon your local cable network. Tell your out-of-town friends they can see us online at ctvknox.org.
Today's show is live, March 15th, 2016, and you can call in on the number on your screen and speak to us while we take a short break. Please watch the informative video about our sponsors.
If you live in or around the Knoxville area and are questioning your religious beliefs or simply believe in one less God than everyone else, well, you're not alone. The Atheist Society of Knoxville is a fun and friendly group of people just like you that meets twice a week at a bar or restaurant. We meet every Tuesday night following the show at Barley's Tap Room and Pizzeria for happy hour. You'll find our group either inside or on the patio. Look for Richard Dawkins' silver-jacketed book, The God Delusion, standing upright on the table. On Fridays, we meet at Agave Azul or the Beard and Beer Market. But if you plan to preach, proselytize, provoke, or punch, please don't. We all question what we believe at one point in our lives. If this is the time for you, come join us for food, drink, conversation, and fun. Do you find stories of talking snakes laughable? Do you prefer the scientific method over supernatural beliefs? Are you concerned about religious leaders and organizations imposing their values and rules on your body, your family, and the rest of our society? Well, take comfort in the fact that you're not alone. The Rationalists of East Tennessee meets weekly for fellowship and provides a forum for people who support skeptical thinking and rational discussion of these and other issues. To find out more information or to find out about our next meeting, visit us on the web at www.rationalist.org.
Well, we're back with you. Just want to point out our sponsors again. The Atheist Society of Knoxville meets once or twice a week. We have evening meetups for fun, food, drink, conversation. ASK's purpose is to supply a venue for community camaraderie to atheists, agnostics, freethinkers, and other like-minded persons in the East Tennessee area. Our Tuesday meeting is going on now at Barley's Tap Room and Pizzeria in the Knoxville Old City. Recently, some of us went to see the new Star Wars movie.
Well, the second Sunday of most months is the Rationalists of East Tennessee Book Club. The title of I guess this is the March book, is the Second Amendment. We just had this past week. Our information's old. Go visit our website, rationalist.org, to find the April book. That'll be about a month from now. You got plenty of time to read it. All right, well, let's go back to our story of stars and dust.
Okay.
So,
we're going to start on globular clusters?
well,
or
the
did we not
star
get there yet?
the star forming region that I was talking about that we can see, that's happening right now. These form loose collections of stars that are usually on the order of 100, maybe 1,000 stars, and it's a self-limiting phenomena where the heaviest few stars form, and they blow the dust away, and the result is kind of like is a collection of stars that you can see through. So they're referred to as open clusters.
And one important thing about them is that most of the stars form around the same time.
Yes.
In those. And as I said, there are a lot of different kinds of stars depending upon their sizes. And so what you get is a collection of stars with different sizes that you think all formed at the same time.
It's like they're all starting a race. They're starting their lives,
right,
so to speak, at the same time, and that plays out later, where we can learn interesting things about it. There was a point I wanted to make, though, that the open star clusters are not the only star clusters we find. There's one more kind of star cluster called a globular cluster, and I guess we got a photograph over my head. And you'll notice this is quite different in appearance. It just gets denser and denser towards the center. These stars formed in our universe when the conditions were quite different. These stars usually have little or no heavy elements in them, or as astronomers say, metals, because to astronomers, anything heavier than helium is a metal.
Yeah.
And when there isn't heavier elements, and there isn't dust particles, stars form differently, and they'll form in bigger clusters, and some of these clusters are left over. It's thought that our galaxy is actually the result of the merger of many of these globular clusters.
Oh, really?
And that there are some still hanging around our galaxy that never fully merged. There is on the order of 150 of these globular clusters surrounding our galaxy. And in fact, it was mapping their position in the sky around 100 years ago that first gave the indication that the center of our galaxy was off in the direction of the constellation Sagittarius. Because when you look that way, you see lots more of these things. And in the other side of the sky is the winter sky, and there are very few of these things in the winter sky. And so the picture that's over Ralph's head shows an artist's view of what our galaxy would look like from a distance. That the plane of our galaxy has this cloud around it of these they've drawn them as red blobs. And a globular cluster is a delightful thing to see, but it's a little bit off the track of our discussion about the lives of stars and story of dust. because globular clusters have little or no dust in them. And there's little or no star forming going on in them right now. So if we move to our next background slide and say, well, when stars form in a nebula, they often form in pairs or even multiple combinations. And multiple star systems are another fun thing that some amateur astronomers like to look at. The stars that are over my head show a nice color contrast as well. Not all star pairs show color contrast, but many do. And the fact that they're in close proximity help you notice that.
Aren't most star systems binary systems?
I would have said multiple, and it may be that binaries outnumber all others. Our star is believed to be a single star system. There's sometimes speculation, could there be a small star that is gravitationally bound to our star? But so far there's no evidence. There's, speculations. And if there is, it would have to be a pretty small one, or we would have known about it by now, either through directly observing its emissions or its gravitational effects.
Yeah.
Now, some stars are far enough apart that you can see them through a small telescope, and in fact, in the handle of the Big Dipper is a star pair that young people will see naked eye as multiple stars. Well, it's two stars. When I was younger, I did. I don't see it as one star anymore. But some stars form so close together that they will interact during their lives. And over Ralph's head, we have an image of one of these things going on. And that's where there are two stars, and the atmosphere of one is leaking into the other. And so these stars can exchange mass, and the mass of a star determines something about how it ages. And so when you have stars that are so close they interact and exchange mass, that can produce behaviors or a life cycle for a star that can never happen when it's all alone. Now, as a star ages, other things may happen. Can we move to the next slide, Sam? So as a star ages, one of the things it can do is it can change size. Now, it doesn't necessarily change size because it's getting more massive. That might happen in those binary pairs that are interacting. But as a star ages, it usually, it may burn hotter in the center, and its outside swells up. And this image above me shows that off to my right, where you can't hardly see it, are little bitty dots. Those little dots are the size of our sun. And between us is this huge thing. That thing is so huge that if you dropped it where our sun was, I'm sure it would engulf Jupiter, if not maybe even Pluto. And that's the largest star in the sky. It's Antares. It's something that's easy to see in the summer, but once again, if you got up right before sunrise this morning, you would see it, and it's the brightest star in Scorpio, the Scorpion.
And when our star ages, it will eventually grow into one of these red giants. And
Not that big, though.
no, not that
Yeah.
not that big, but
It might get
could-
about as
it
big
could
as this one
engulf-
over
it
my
certainly
shoulder
engulf,
kind of thing.
Mercury and Venus, and probably the Earth, and maybe even go out a little farther.
Yeah. And as it does so it will grow. Its outer surface will grow. It will get cooler. It'll be redder. And these are called red giants.
Right.
When the sun sets tonight and you go out and look at the Orion constellation, as you look at it to your left, which is to the east, there is a bright star that has a noticeable color to it. You would call it orange or perhaps red. And it's Betelgeuse or Betelgeuse, and it may be the one that is over here. So it's a large star as well. And although it's depicted as huge, and it is more massive than our sun, it's probably something only on the order of, let's say, 10 times as massive, even though its physical size is hundreds and hundreds of times. So it's actually a very not dense thing.
Right. What we should point out to people is that stars are in sort of an equilibrium, or at least slowly changing equilibrium, where the gravitational forces try to pull it in are balanced by the radiation pressure trying to push the components of the star outward. And so these change over the history and the type of heating that goes into stars, and that's why the star grows. As you say, it doesn't necessarily get more mass, but the balance between the pressure and the gravitation changes.
So a word that is used is to say that the star evolves. The word evolve has a very different connotation, or it describes a very different mechanism than when that word is used for biological systems. Because in biological systems, evolution involves the change from one individual to another, the life and death of an individual. This change that happens to a star is a rearrangement of its equilibrium situation. Now, stars of a certain mass range, as they evolve, they go through a period where they don't shine stably, where their brightness will increase and decrease in a regular fashion. These are called Cepheid variables, and the very first of which was discovered in the constellation Cepheus, or Cepheus. And that particular star, I think this is Delta Cephei, and it has a period that is something like about 2.5 days. And so if you watch that star and compare its brightness carefully to stars nearby it over the course of an evening, and then the next evening, and then the next evening, you'll see it increase and decrease its brightness by a noticeable amount. Now, it's not a huge amount, but it's an amount that you can see and perceive with your eyes. And although I've not done Delta Cepheid myself, I've measured with my naked eyes the light curve of one that's in Gemini. Gemini is, if you go out tonight and you find Orion, Gemini is to the upper left of it, and there's a star there that is a naked eye variable. And it's a fun thing to do. It has a period that's closer to like 10 days.
Yes. These are extremely important stars in trying to understand the structure and the size of the universe, because their maximum brightness depends only on the period with which the luminosity changes. And therefore, you can measure the apparent brightness that you see and relate it to the absolute brightness of what that star is, and that's how you tell how far away it is. So these are standard candles for objects that are not too far away.
For things within our own galaxy. However, Edwin Hubble measured the distance to the first galaxy outside our own by using stars of exactly that type. Yeah. He observed Cepheid variables in the great galaxy in Andromeda. Let's move to the next slide. So as a star burns through its fuel, it becomes unstable, and eventually, as it runs out of fuel, it rearranges even more dramatically. So this is an object, once again, this will be visible. This one's probably visible by midnight this time of year, certainly by around 2 or 3 in the morning. This is called M57. It's the Ring Nebula. It is a star that is blowing off its outer shell, and it's they're called planetary nebulas because, unlike stars, if you put magnification on them, they do actually get bigger, kind of like what planets do, but they're called nebula because nebula was a word meaning cloudy. And planetary nebula are some of the most beautiful things that Hubble Space Telescope has shown us, because the Hubble Space Telescope lets you also break the colors down that are indicative of particular atomic types. This image here is not natural color. Your eyes would not see this. To the human eye, I have seen color in this object a few times, and that color is usually just a kind of a bluish cast to it. And it may be that I'm sensing some of this stuff inside as part of the blue. Human visual acuity under low light conditions is not real good. But this is how a small star ends its life. Let's move to the next slide. Big stars end their lives very differently. Big stars instead of blowing off their outer surface gently over a period of time, well, they do blow off some of their outer surface, but then what happens is their center will run out of fuel and it'll collapse and violently produce then an explosion. So over Ralph's head here is M1. This is the first Messier object, which is the first object in a catalog by a guy who was looking for comets, and it's the first object he cataloged that was not a comet so that it wouldn't get mistaken. This is right over the horns of Taurus the Bull. You can see that tonight with a small telescope. These things get so bright, here we go, that when one of them goes off, they'll produce as much light as the whole galaxy that they're in. And so this is a photograph of a galaxy that has a star that's gone supernova, and you see that that one star is quite bright and is producing as much light as a whole galaxy. Next slide, Sam. So stars come in all sizes, and this is called the Hertzsprung-Russell diagram. Small stars near Ralph here are not hot, and they glow red. Bigger stars glow white, and very big stars glow blue. Very big stars are the ones that end in that supernova, and they burn through their fuel really fast. Some of them will do it in like 10 million years, the heaviest ones up there.
Yes, that's because you think if they're bigger, they might take longer to burn up, but because they're bigger, they also are much hotter, and they burn very much faster.
The equilibrium condition is quite different. So they run through their fuel really fast. And when they run through the fuel, they blow up and shed the heavy elements into the universe. The Ring Nebula is shedding light elements because that star has never got heavy, it was never able to make heavy elements. And so you're going to get oxygen and carbon and silicon from those kind of stars. But to get things like lead and gold and uranium, that takes the supernova of a really massive star. So when you go out under the night sky, let's get our next slide up, Sam. When you go out under the night sky, and if you go to a dark place like the Cherahalla Skyway, you can see our Milky Way, and cutting across it is this dust lane, this darkness. That is material that is capable of and is forming new stars right now. And in fact, there's enough dust there that our galaxy may be able to make more stars than it currently has. In other words, our galaxy is still kind of young.
Yeah.
And what is so marvelous to do, and that no photograph can appreciate, is to stand under the night sky and look at that. Because when we look at a photograph, we're looking at something and we feel like we're outside of it. But under the night sky, when you look up, it surrounds us, and you realize that we really are in this city of stars.
Yeah. And we should say that, again, repeat that most of the atoms and things that we're made of, that everything you see is made of, come from these supernovas that have exploded and put it out into space. So it's about time to get to our program closing.
All righty. Well, get out your pen and paper. This has been Freethought Forum, a program by the Atheist Society of Knoxville. I'm Faithless Forrest.
And I'm Ralph Eisler. So please send us feedback. Leave voicemail at 865-272-9060.
You can see this show on most Tuesdays from 5 to 6 p.m. On this Knoxville station, or anywhere the internet reaches at ctvknox.org.
Okay, the opinions expressed on this show are of the hosts and guests, not any official opinion of Ask and RET. I'd like to thank Sam for technical support and the staff at CTVKNOX, and to all our viewers and callers.
All right. Thank you for watching, and